All right, so on to our next lesson in sequences and series, and this is recursive formulas. So first off, what is a recursive formula? So sequences can be defined recursively. Recursively defined sequences give one or more of the first few terms, and then define the terms that follow using those previous terms. The formula defining the nth term of the sequence is called the recursive formula. So before we start here, this is what a recursive formula looks like. So if you look, it gives the first term, and then basically it tells us how to get each term after that, okay? So I can show you a mathematical representation of this, and I could also show you how to be able to read it like it's a language. And if you're able to read it like a language, it is so much easier, okay? So let me teach you that language first, and then I'll show you how to do it mathematically and be like, don't ever do that again, and we'll use the language, okay? All right, so a sub n you already know, that's the nth term or the current term, right? So that's the term that it is currently trying to find. A sub n minus 1 is the previous term. The previous term. Okay, and then a sub n minus 2 is the term before the previous term. Do I really want to write that down? No, I don't feel like it. It's the term before the previous term, okay? This is the next term. And then this is the term after that, right? So like if you're able to read it, right, it's much simpler, okay? So here are the directions for these. It says each sequence is defined recursively. So this is how it looks when it's defined recursively. Where n is greater than or equal to 2, it'll always say that. Find the first 5 terms of each sequence. So I'm looking for the first 5. I know a sub 1 is 3, and then I'm looking for the second term, third term, fourth term, and fifth term. I'm just doing this as like a skeleton to help us realize what we still need to get, okay? So first I'll show you how to do it algebraically, like using values, okay? And then I'll say, now let's just read it and get the answers. Okay, so to get a sub 2, the second term, because we already have a sub 1, it says to do 4 minus a sub n we have is 2 right now, minus 1, so this is 1. So it's saying do 4 minus a sub 1. 4 minus a sub 1, which is 3, is 1. See that? Let's get the next one, and then let's stop doing this, because it's just, I know how to do it by reading it, right? To get a sub 3, you're going to do 4 minus a sub 3 minus 1, which is a sub 2. A sub 2 is 1 right here. So you're going to do 4 minus 1, which is 3. All right, so that's how you do it mathematically. If you want to do it that way, I will never stop you, okay? But I will encourage you to listen to this, okay? This means the previous term. So the rule is 4 minus the previous term, okay? So let's say I don't have either of these. If I want this term, it's 4 minus, I don't like that it's that. It's 4 minus the term before this. The term before this is 3. 4 minus 3, 1. Okay, if I want the next one, it's 4 minus, that's the rule, I'm just remembering it from over here, 4 minus the previous term. The previous term is 1, and I get 3. It's 4 minus the previous term. The previous term is 3, so I get 1. It's 4 minus the previous term, which is 1, so I get 3. So there's my first 5 terms. Okay, if you don't like that way, that's fine, but I'm going to continue to teach it that way because it's easier, okay? You could always do it by plugging in a value. All right, so if you think you don't like it, just listen. I need the first 5 terms. I know 64 is the first term, and then I need the second, third, fourth, and fifth term, okay? So this says take half of the previous term, okay? So to get the term, I take half of the term before it. So if I want this term, I take half of the term before it. Half of 64 is 32. If I want the next term, I take half of the previous term, which is 32, and I get 16. Half of the previous term, 8. Half of the previous term, 4. Right? If you can read it, notice that there's not much work to do. Okay, let's move on to the next one right here. So this one gives me the first two terms. It says the first term is 3, the second term is -1. I need the third term, the fourth term, and the fifth term. Okay, so I just have to be able to read this. All right, so this says do 2 times the previous term, all right, plus the term before that. 2 times the previous term plus the term before that. So I'll write down a little bit of work of this so that I don't lose the language. I'm gonna keep this up. Say it one more time before I move over. 2 times the previous term plus the term before that. 2 times the previous term, which is a -1, plus the term before that, 3. See, it's not bad. All right, so 2 times -1 is -2, plus 3 is 1. Right, and you can use a calculator, obviously. It's not that difficult to do this without a calculator. All right, 2 times the previous term. So the previous term is this one right here, which is 1, plus the term before that, this one right here, -1. So 2 minus 1 is 1. 2 times the previous term, which is 1, plus the term before that, 1. 2 plus 1, 3. All right, there's your list. I wish these were like numbers like 17 and 36 so you can like really see the difference, but there's a lot of 1s and 3s going on in here. But it's just 2, so if I wanted to get the next one, okay, just so we can keep going here. 2 times the previous term, which is 3, plus the term before that, which is 1. 2 times that term, whatever this is, plus this term right here. Okay. Here's this one, okay? All right, so my first 2 terms were given, 1 and 1, and then I need the next 3 terms. All right, so this says take the term before the previous term plus the previous term. Say that again. Take the term before the previous term plus the previous term and add them. So this is actually really easy. It just says take the term before the previous term, which is this one, and add this one to it. And with addition, it doesn't matter the order, so 1 plus 1, and I get 2. On this next one, take the term 2 terms ago, which is 1, and add the previous term. 1 plus 2, 3. This one, 2 plus 3, 5. And there's your list. All right? So if you look at my work, it's just that I don't get lost in my own head here. But if you know how to read it, super simple. Okay, so last but not least, we will write recursive formulas. We want it to look something like this or like this. A lot of ours will look like this to start, okay? Because we'll say, here's the first term, here's how you get the next term. So if it is arithmetic, okay, if there's a pattern by adding something, you're going to say what the first term is. You're going to say a sub 1 is, and you're going to tell what the first term is, okay? And then you're going to say how to get the next term. So you're going to say you're going to take the previous term, right, and then add the difference. For geometric, very similar. You're going to say what the first term is, and then for your rule, you're going to say you take the previous term and you multiply it by the common ratio, r. Okay? All right, let's go try a couple of these, and all that you're doing is building off the previous terms. So this says determine the next 3 terms, so we have to find the pattern here. So 10 to 7, 7 to 4, 4 to 1. This is -3. So your difference is -3. Your first term is 10. And then let's continue to find the rest of the terms here. So -5, -8, -11. Right? And it says the next 3 terms and has 4 spots. Interesting. Now, if I wanted to write an explicit rule, okay, if I wanted to write an explicit rule, that's what we already learned how to do, explicit formula or explicit rule. So let's make sure we know the difference between that and what we're doing. An explicit formula or explicit rule is a sub n equals a sub 1 plus n minus 1 times d, okay? And then we would do a sub n is equal to the first term, which is 10, plus n minus 1 times the difference, which is a negative 3. Clean that up, so it's 10 minus 3n plus 3. So a sub n is equal to negative 3n plus 13. That is an explicit formula or an explicit rule. A recursive formula doesn't look like that. So this is an explicit formula. A recursive formula is you say the first term, a sub 1 is equal to 10. And then now you're going to say how you get each additional term. And that is you take the previous term, so you would take 10, right? So to get this term, you would take 10 and you would subtract 3. To get this term, you would take 7 and you would subtract 3, right? It's telling you how to do that. So this is how you write a recursive formula, which, let's be serious, is easier, less work. Okay? All right, next one here, determine the next 3 terms in each sequence. Once again, it gives us 4 spaces, so that's slightly confusing. All right, so if you look, it seems to be that it's dividing by 2, which is the same thing as multiplying by a half. So our R value is a half, and our first term is 96. So let's continue to multiply by a half. 12 times a half is 6, times a half is 3, times a half is 3 halves. All right, let's do both. So let's do an explicit formula to make sure you know the difference between the two. Explicit, I know how to spell, I swear. Explicit formula would be a sub n equals a sub 1, which is 96, times r, which is the 1/2 to the n minus 1 power. Not a lot of work for an explicit formula, right? But let's also do the recursive formula, which is not a lot of work either. A sub 1 is equal to 96, your first term's 96, and then to get each additional term, you take the previous term, so I would take 96, or the term before it, and I would multiply by 1/2. So I'm going to move this over a little bit and say times a half. Voila. Okay, so let's just make sure we know the difference between what a recursive formula looks like and an explicit formula. All right, that's it for today. You can get started.